Today we will discuss about Venn diagram. So the series of this discussion, we have discussed different type of set and why the need of the Venn diagram to discuss in this chapter. Let us understand. Most of the relationship between sets can be represented by Venn diagram. Most of the relationship between set we can represent with the help of the Venn diagram so that we can easily understand of the relationship between the set. These diagram consist of a rectangle and closed curve, usually circles. This is a rectangle and this is a circle. Okay. So, the universal set is represented usually by the rectangle and it subset by the circle. Circle, this represented by the universal set, and this is basically a circle represented as a subset. So we can also represent element of the set in the Venn diagram. So in Venn diagram, the element of the set are written in their respective circles. Suppose that figure 1.1 and figure 1.3. So let us understand in figure 1.2 universal set is 1, 2, 3 up to 10 is the universal set of which A is equal to 2, 4, 6, 8 and 10 is a subset. So subset we can represent in the circle, and element 1 to 10 we can represent in a universal set which is in the rectangular form. This is a rectangular form. Rectangular form. So basically this is a representation of a Venn diagram, and after that the second example is if U is equal to this is the universal set of which, so A is equal to this and B is equal to this, are subset of subset and also B subset of A. So this is A and this is this circle, inside circle, coincide circle represent, this circle represent B and this circle represent A. So B circle inside the circle A, so B is a subset of A. B is a subset of A. And element of set B 4 and 6 and element of set A 2, 4, 6, 8 and 10. So this is a 2, 4 is also here, 8, 6 and 10. 4 and 6 both are common in set B and set A. So that's why we can represent like that. We cannot represent 4 here, okay? Because 4 and 6 are common in set A and set B, so we can represent in the set B. So B is a subset of A and A is a subset of union set, so B is also subset of a union set. So basically this is a representation of a Venn diagram. Venn diagram, when we discuss the union, intersection and differences of the set. After discussion of union of the set, intersection of the set and difference of the set, we can understand more about the Venn diagram. So first of all, let us understand the operations of the set. This is the second heading for today. So operation of the set, we have already learned about and discuss about and do about the operations of mathematical algebraic operation like as addition, subtraction, multiplication and division. So these operations we have already discussed in previous classes. Now in the set, how can we use operation of the set? So for the addition can replace the replaced by the union set, union of two set, union of sets. Okay, and subtraction replaced by the intersection of the set, intersection of sets. We can find the intersection of the different type of set, union of the different type of set, and difference also we can find of the sets. So basically these are the operations: union of set, intersection of set. These are the operations of the set. These are the operations of sets. Okay, these are the operations: addition, subtraction, multiplication, and division. These all are the operation of algebraic operation in mathematics, but these are the set operations. So how can we use all these set operations? So let us understand one by one. Union of the set. Let A and B be any two set. So the union of A and B is the set which consists of all element of A and all element of B. The common element being taken only once. The symbol this is used to denote the union of the set. Symbolically, we write A union B. A, this is a union, and B. This is a union of two set. Union of two set. Union of two sets, and usually recall as A union B. We can read as as A union B. This we can A union B. How can we find A union B in the set? So let us understand with the help of example. Let set A contain these elements. This is a set A and this is a set B, and find A union B. So A union B is 2, also come here, 4 come, and 6. 6 element is in the set A and this is also in set B. So in the union we can put only ones, and 8 is the element of set A. 8 is also the element of set B, so this also come once. And 10 and 12 not present in the set A, but both will come in the union of set. 2 and 4 also in the set A but not in the set B, so 2 also come here. Basically this is a union of two set. Every element come once in the union. Suppose if we have to calculate the union of the two set, so each and every element from the both set according to the definitions come in this set. So this is a answer of these questions or this example. Note that common elements 6 and 8 have been taken only once while writing A union B. And now understand the example number. Let us understand example number 13. Set A is A, E, I, U. These are the element of the set A, and set B have contained three elements, so that A union B is equal to A. We have to show A union B is equal to A. So first of all, just calculate A union B. A union B, A, E, I, O, U, A, I, O. These all are present in this set. So we can write like that. And this set is a basically nothing set A. So this is because of that A element A is present in the set A, also present in a set B. It will comes once in A union B. And element E is present here but not here, but also come here. Element I present here in the set A, and element I also present in the set B. So it is also come in the this. So this whole A union B is equal to the set A. This example illustrates that union of a set A and its subset B is the set A itself. We can also write like that. B is a subset of A, and then A union B is equal to A. If in the question asks about the subset, so we can write B is a subset of A. Now let us understand another example. Set X is equal to Ram, Geeta, Akbar. Be the set of the student of the class 11th who are in the school hockey team. Let Y, Geeta, David and Ashok be the set of students from the class 11th who are in the school football team. Find A union B and interpret the set. So that is a solution. A union B, Ram present in the set X but not in the set Y. It will come here once. Geeta present here, Geeta also present here, it will come once. Akbar present here, Akbar not present here. David and Ashok in the set Y but not in the set X also come here. So basically A union B is this set. This is the set of the student of class 11th who are in the hockey team as well as in the football team. So, or some of the students are in the football, those are not in the hockey team, but some of the student, not some of the student, only Ashok, Ram and Ashok. Ram, only Ram not present in the for football team. So basically this is arrangement. Thus we can define the union of the two set as the follows. Definition next. The union of two set A and B is the set C, which consists of all those elements which are either in A or in B. Those which are in the both. In symbols, we write A union B like that. Mathematically, we can represent like that. A union B is equal to X such that X belongs to A or X belongs to also in B. Basically the definition, above definition also talk about this. We write the union of two set can be represented by a Venn diagram as shown in this here. So basically rectangle part represent the universal set, and circle part represent the subset. And here this set A represent this circle and this set B represent this circle. So this is a common part of this Venn diagram. If those elements are common will come in this common part. Those are not common will come in the, suppose some of the element present in the set A not present in the set B. So those are present in set A come here, and some of the elements suppose not present in A and present in B, so they will come here. And those are common in set A and set B, they will come in the common part. In this common part, they will come. So basically this is a union of set, and union of set present whole part, this whole part present the union of set. So basically this is a representation of the union of the set. Now some properties of the operation of the union. First properties we have already discussed about the commutative commutative properties, associative law, commutative law, and law of identity element. Phi is the identity of a union. We have discussed in previous classes. So like 7th 8th classes, in 7th class and 8th class we have also discussed a plus b is equal to b plus c. So basically we have discussed commutative law in 7th and 8th class, same as it is here. There are two set here operation. This is a operation with two numbers, and here this is a operation with two set. So A union B is equal to B union A. This law is called a commutative law. And A union B union C and A union B union C, this is a associative law. And the A union phi is equal to A. This law is called a law of identity element because phi is the identity of the union. So these are the important law for our study, and this is also A union A always equal to A. This is called a idempotent law. And union, this is a universal set. Universal set. So universal set union set A is equal to universal set. This is called a law of universal set. So basically this is a representation of a union of set. So I hope so you understand the union of set and little bit the Venn diagram. We will more discuss about the Venn diagram when we have to discuss first of all intersection of the set and subtraction of two set, and after that we will explore the Venn diagram. Okay, thank you so much.